View encapsulation defines how our CSS is applied to components on our page. Imagine this as our page, and it has 4 components. When we define CSS selectors, view encapsulation controls where on our page those selectors have an impact. For example, affecting 3 of our 4 components. You can control how this happens by setting the view encapsulation property on your component. Before we go any further, we need to take a short detour to discuss Shadow DOM. We're not going to dive deep into the bowels of Shadow DOM, just a quick overview, enough so that we understand how it applies to Angular and view encapsulation. In fact, I'm going to focus really on just one aspect of it, DOM isolation. Without Shadow DOM, the DOM of your page was a single monolithic thing. Any CSS selectors in the page applied to the whole page, and everything in it. The terminology reflected this. People spoke of the DOM or the page DOM, and all kinds of silly problems arose with conflicting CSS selectors and weird JavaScript written to filter out undesired elements. The important designation in CSS was one attempt at remedying some of the problems presented by having a single DOM. With DOM isolation, that all changes. We no longer have just the singular page DOM. Now we can have individual component DOMs. Together, these component DOMs make up the page DOM, which does still exist, but we can deal with the component DOMs individually. With that aspect of Shadow DOM understood, now we can discuss the options for view encapsulation. There are 3 options for view encapsulation in Angular. Emulated, Angular is going to force encapsulation even if the browsers don't support it. Native, Angular is going to rely on the browser's built-in support for encapsulation. And none. All encapsulation is turned off. Emulated is the default, and you've seen this even if you didn't know what it was you were looking at. Emulated is what causes Angular to add attributes like this to the elements in our DOM, and also to rewrite our CSS to add specificity to our selectors, forcing them to only match elements within our component's scope. Native and none do not make any changes to our markup or CSS, because native is relying on the browser's built-in support for Shadow DOM, and none is not using Shadow DOM, so in each case, no modifications are necessary. The effect of all this on our CSS and our markup is as follows. Starting with a component inside a page, each having defined styles, emulated allows the CSS defined in the page, typically in our global styles.css, but potentially in any style sheet referenced directly in index.html or angular.cli.json, or any styles added directly in index.html. These are going to pass freely into our component. However, styles in our component are prevented from impacting anything outside of our component's scope on the page. Starting from the same point with native, external CSS from the page is prevented from impacting elements in our component, and styles in our component are prevented from impacting elements outside the component. In late 2017, the only browser with any real support for native Shadow DOM is Chrome 60 and better. With view encapsulation set to none, external page CSS is allowed into our component, and our component CSS is allowed out to impact the page. Let's go take a look at this and see how and when we can use it in a demo. Taking a look at view encapsulation, I have a somewhat contrived example, but I want to use it to show you both the capabilities of changing the view encapsulation, but also the repercussions of changing it. So if this covers what you're trying to do, then it's a good thing. If it happens as a side effect that you weren't really expecting, well, then it's something you're going to have to deal with. So what we have on the screen here is 2 different widgets. We have View Encapsulation and View Encapsulation 2. Inside View Encapsulation, we have a parent component with a colored block inside it. The block is green. All of the blocks are green. We also have a child component above that with the colored block. And then over on the right-hand side, we have a totally separate widget, a totally separate component, not really in any way related to the one on the left, that also has another colored block in it. Now, my requirement is that in certain situations, I need to change all of these colored blocks to a different color. We're going to say blue. I want to be able to do that as quickly and easily as possible. So let's jump over and take a look at what I think is a pretty straightforward, pretty easy way to go about doing this. I can come in here, and I'm just going to uncomment this additional child component. Go ahead and save. jump back to my browser. Now I'm going to reload those widgets, and you can see that all of my colored blocks have switched to blue, which is exactly what I want. By adding that second component, I've said in this situation, I want all the colored blocks on the page to be a different color. So how did I do that? All I did was include, as you saw, this second component. That second component includes the CSS rule that changes the background color of all the colored blocks to blue. The way I got that to apply to all of the colored blocks on the page was by changing the View Encapsulation setting for that child component too. I changed it to View Encapsulation None. And you can see this is how we go about changing it. It's in our component decorator. We say encapsulation, colon, and then the encapsulation that we want. And by setting it to none, what that's done is it's basically taken this CSS rule and put it unqualified into the page. So it doesn't have anything that's going to say this only applies to child component 2. It now applies to everything on the page. Because all of my other components are still using the default view encapsulation, they're going to accept any CSS from the page itself. Which means that by simply having that on the page, I'm going to change all of the colored blocks. Now, if I were to go and reload this page for a second and load View Encapsulation 2, you can see that one's going to be green. So until I go and load something that has that page-wide rule, it's not going to come into effect. Now you could say, well, there's other ways to do this, and sure there are. I could write some code that says, go out and find all the colored blocks and change their background color. But now I've got code that's running. By doing it this way, I'm letting the browser do it. The browser says this is a CSS rule that applies to the entire page. Here I've got a component on the page that matches that rule. The browser's just going to apply it. I don't need to write any code specifically for that.